your solution. Number 3, small cells. This is a single carrier solution, and it is governed by the regulations governing cellular operations. The thing to note about this type of solution, and you may have seen the ads on TV for a couple carriers, I won't name them, but it's a solution for one carrier, and it's sold by that carrier. It's less expensive than a DAS, more expensive than our CellBoost product, but if you've got a problem with one carrier in your building, the first place you may start is that particular carrier may come into your building. They may put a DAS in on their own dime. They may charge you a small cell system. They may put a small cell system in and charge you. They may put it in on their own dime, but it's a single carrier solution. So typically people who've got one building with a preponderance of users using one carrier will look at this type of solution to solve the problem. As a note, you should continue to follow, obviously, the space because this is changing pretty rapidly, but in Q4 of this year, Ericsson will be releasing a product called the Dot, which has gotten a lot of press and play. It will be a single carrier distributed small cell solution, and we understand it will also have an optional Wi-Fi component. So keep an eye out for that for a potential solution for some of your buildings where it's a one carrier problem. Solution number 4 is our product. It wouldn't be a webinar if it wasn't a sales pitch. So our product, CellBoost 2.0, is what we would call a hybrid DAS. It boosts the signal inside of a building from a donor antenna. So the difference between this and a full-blown DAS is in a full-blown DAS, you're probably bringing in the signal source from a base station. This product requires the signal source to be brought in from a donor antenna on the rooftop. So it still must adhere to the network performance standards as set out in the report and order from the FCC. It still needs carrier approval. It is carrier specific, so that if one carrier wants to turn the frequencies off, it can do that. But it absolutely requires that a donor signal for that cellular carrier be present at the location where you're putting the donor antenna. It's about half the price of a DAS. It's carrier neutral, and also gives you the ability to plug in a first responder module if you've also got that requirement in the building. This is the kind of solution that's best for medium and large MDU, MTU type buildings that, again, has adequate outdoor cell signal, and that's really the primary issue. You've got to make sure you've got outdoor cell signal before you deploy this kind of solution. Last but not least is, from our perspective, the most exciting thing going on in the space, and it's Wi-Fi calling, which from our perspective is the voice answer to Wi-Fi as the data answer. And for those of you who've been Skype users or Google Voice users, you know how one part of this service works, the over-the-top service. You connect to a Wi-Fi hotspot or Wi-Fi network. You can then make a call using one of those products. The carriers, specifically T-Mobile and Sprint, have over the last few years, in the case of Sprint, in the case of T-Mobile, I'm sorry, and Sprint just recently, started to support Wi-Fi calling natively to their smartphones. And the way that service works is that the firmware on the phone has been modified, and the carrier supports on their back end a Wi-Fi handoff, so that a user with a smartphone in a building that doesn't have cellular service could connect to a trusted Wi-Fi network and use their phone to make a phone call just as if they were connecting to the carrier network. You don't even know you're making a call over Wi-Fi. And that's the difference really between that kind of service and a Sprint service where you have to physically connect to the network, break up a separate application, and run that. A lot of people will do that, but frankly, the way Wi-Fi calling needs to end up is it needs to be embraced by the carriers and be native to the firmware so that a user doesn't have to do anything when they hit the dial button on the phone. T-Mobile now supports that right now, and Sprint has just announced they're supporting it. So from our perspective, that's where this is going to end up. Couple announcements that, from our perspective, buttress that fact. One just came out from Apple. I don't know if those of you who remember back in 2007 when Apple changed the way the phone was marketed. Before that, the carriers really determined how phones got sold to customers, what feature sets got turned on. Apple just made an announcement recently that we think is going to transform how Wi-Fi calling is done over these networks also. And if you didn't see the announcement, here it is. On June 2nd, at the Worldwide Developers Conference, they announced that iOS 8, which is the operating system on the Apple devices, will support seamless Wi-Fi calling on Apple smartphones. T-Mobile will be the first ever to support seamless Wi-Fi calling. The public is going to see this, and frankly, from our perspective, it's going to drive Verizon and AT&T to also support these features. Right now, if you have an Android T-Mobile phone, you can do Wi-Fi calling. This announcement means that all Apple devices will be equipped with this feature, and T-Mobile and Sprint will be the first carriers to support it on their networks. So our belief is that just as Apple transformed the way cell phones were sold, this perhaps will drive AT&T and Verizon and some of the other carriers that don't natively support Wi-Fi calling to support that on their network. So we're very excited about that for the future of Wi-Fi. So what's the conclusion here? The conclusion is, in the short term, from our perspective, you want to buy the most cost-effective and technically appropriate solution to meet the needs, especially for voice issues. You want to keep an eye on the market to follow carrier support of Wi-Fi calling. Our view is once Wi-Fi calling is universally adopted, there will be a significant decrease in the need for indoor cellular solutions. Okay, we got a couple questions. First question, how long does it take to get carrier approval? Thornton, you want to take people through the process?
Well, with carrier approval, it really depends on how fast, because the FCC basically leaves it open to interpretation that the carriers need to give you the approval within a reasonable amount of time, which, you know, is up to each carrier and person's perception of reasonable. For the consumer boosters, you just have to register online. Each carrier has an online registration process, but for the industrial boosters, it has to go through the representatives for each carrier that you want to use for the booster signal. And generally, if they are responsive, it can take a couple weeks. If they're not responsive and you have to go through multiple revisions, it can take a few months.
Okay. Another question here, why are industrial boosters not suitable for MDUs?
Well, this is Matt. I'll just jump in. I would say they're not. I don't think that's. I don't think we've been saying that. What we've been saying is that the consumer boosters probably are not. I mean, a DAS is essentially an industrial booster installation with some other features. So yeah, maybe we weren't clear about that earlier.
Yeah, I think from our perspective, Matt, I mean, the issue with the industrial boosters is most of them are wideband, and it will be difficult to get carrier approval on wideband BDAs from what we can see. The report and order also made it pretty clear that they thought the approval process for industrial BDAs basically should follow the DAS approval process. So you had an opportunity, the FCC had an opportunity to take these boosters and maybe have an exemption or a special case for MDUs, which might be the most appropriate place for the use, but really threw them back in the DAS camp in terms of their approval process. So I think they're suitable, but I don't think the building owner is going to find that going through the approval process is going to work, especially when it's a wideband. It's going to take one carrier to turn it off, and then the whole system needs to be turned off.
Yeah, I agree.